All right, and now we are going into our next chapter under the phylum Chordata. We're going into Reptilia. Again, you guys should be pretty familiar with most of the organisms in this category. So in this group, you're going to find snakes, lizards, turtles, tortoises, alligators, and crocodiles. Like always, their name meaning. Reptilia comes from reptilis, which means creeping or crawling. You can see why that fits this category. Pretty big group, 10,000 species. Not huge, but as we go forward, you're going to see these numbers increase a little bit. All right, you can find these guys in freshwater. You can find them in the ocean, obviously if you're a sea turtle, or on land, terrestrial. Those are going to be your snakes and lizards, etc. They're actually found on every single continent that we have on Earth except for Antarctica, because just like our amphibians, these guys are ectotherms. So they have their body temperature regulated by the outside temperature. So obviously Antarctica is very, very cold. These guys would not survive there. Guys are the first vertebrates that we have that are not tied to water. They do not exclusively need to be in the water. Remember, amphibians were stuck nearby water to keep their skin moist and so that they can lay their eggs and that they don't dry out. Reptiles have now evolved to be able to live far from water, and that allows them to, explore other habitats, find food, find mates, and that's why they are so much larger than our amphibians. Like I mentioned before, they are ectotherms, or they are cold-blooded, which means their body temperature depends on what temperature it is outside. Ecto means outside, therm, like thermometer, means heat. So they rely on basking in the sun, right? If it gets really cold, if you have a turtle or a bearded dragon and it gets really cold in your house, you will see them scoot underneath the little basking lamp to warm up their bodies. You've also seen that in the cold here, the famous iguanas falling out of trees. That is because it gets so cold that their bodies actually temporarily hibernate. They shut down, and that's why they fall out of trees, because they can't hang on like they were before. And then as soon as their body is warm, they will come back to life, as long as it is not too long. So the darker their skin color as well absorbs more heat, just like our amphibians, and the lighter it is, the cooler they get, but very dependent on the outside temperature. These guys are covered in waterproof scales. Some are modified into claws, horns, rattles, and scutes. Scutes are what we call the little diamonds on the sea turtle shells, or in that picture there as well. Tetrapods, right? We've heard that before, have 4 limbs, and snakes are still considered tetrapods, even though they do not have legs. This is more of a developmental change over time. The ancestors of snakes did have hind legs, shoulders, and hips, but they kind of evolved out of that. These guys are what we call amniotes. This changed the game for reproduction for animals. Humans are amniotes. That means that we develop in an egg with an amnion, or amniotic fluid, a protective membrane. This includes reptiles, birds, and us, mammals. Amphibians and fish are not amnions. Okay, that means that they are not going to be protected by this little internal membrane. The amnion is what holds the embryo in place and keeps it from drying out. Remember, fish obviously are in the water full time, but amphibians needed to lay their eggs in water so they don't dry out. So this is kind of that one-step benefit to reptiles being on land. Okay, so once they kind of evolved onto terrestrial living, they have a couple things that make them able to actually do that. So they have those waterproof scales as their external covering. Their scales are made of keratin, same thing that we have as hair. Also, our nails is keratin protein as well. Your hair does get wet, but it wicks away moisture and it will dry out quickly. Same thing here. Their scales and scutes will get wet, of course, but within a little bit, they will dry out very quickly. Reptiles rely solely on lungs for breathing. They do not breathe through their skin. It is way too thick. Okay, those scales are very, very thick. Amphibians did not have that issue. They had that moist skin and it was kind of porous so that they could have oxygen exchange. These guys have a strict lung. Okay, they never have gills. They have lung full time from birth, and they breathe through that one lung. These guys can lay eggs on land because of that amnion. They also are the first to have a protective outer shell. Okay, so this was huge for the switch from amphibians to reptiles. Amphibians don't have shells, they just have that goo around their shells not to dry out. These guys have a full hard shell. Turtle shells actually feel like little ping pong balls. They're not hard like a chicken egg, but still protective enough that if you push in on it or it gets trampled by the other turtles coming out of them, they kind of do have a little bit of protection there. Reptiles undergo what we call development without metamorphosis. This is direct development. Okay, so they are born as miniature versions of adults. Turtles we call baby turtle hatchlings, and then they turn into adults. So they're just a baby version. If we compare that to our amphibians who go through indirect development and metamorphosis, remember they have that larval stage, a tadpole, and then an adult with all different body forms. Okay, reptiles do not do that. The amniotic egg, this is their claim to fame. Okay, so this is what happens if you have an egg with an outer shell and inner membranes. This is double layer protection. Okay, so within our chordates, our phylum Chordata, all of these guys have amniotic eggs. Okay, so your sharks, amphibians, fish, reptiles, birds, mammals. Though they look different for each one, they are amniotic eggs because they have an outer and an inner membrane. Okay, so again, more reptiles, birds, mammals, platypuses, and echinidas. The benefits to these are protection, okay, from the eggs or the embryos and babies moving around. Predators, it's way harder to eat. Parasites keeps things out. We talked about not drying out while it's on land. They're able to have all of the nutrients and water that they need until development inside the egg. Gas exchange is easy through that shelled barrier, and also same with waste removal. Okay, so it's just a very strong barrier for them. Okay, so we're going to label parts of the amniotic egg. So on the very outside, we have our shell. Okay, you guys have seen a chicken shell or an egg shell, same thing, that hard external membrane. And then inside, everything that we're going to label is just, sorry about that, protecting the embryo inside. Their shell is made of calcium carbonate. Just like our seashells, right? We've heard that before. Protects from damage, predators, infection, drying out, but it does have tiny pores that allow for oxygen and CO2 exchange. Some reptiles have a little bit more of a leathery shell, like our turtles, but the shell is watertight and prevents water loss in or out. The only time that water can completely destroy a shell, especially turtles around here, if their turtle nests underground are washed over by the ocean consistently, they can drown those eggs, unfortunately. Then on the inside, we have this tiny, I can zoom in here. Mm. Okay, they have this tiny little section here outside the embryo that is called the amnion. And then inside the amnion, all around baby, is the amniotic fluid. And that fluid cushion, okay? It's basically just protection for the embryo, give it a little uh, like a water bed. So if it gets hit, like for example, if my stomach were to get hit while I was pregnant, there is a little resistance there just because it got hit. It's not like you're hitting the baby directly. There's fluid that acts as kind of a buffer in between. When your parents, as moms, when their water breaks, that water is the amniotic fluid. It's not just like a puddle of water. It is this amniotic fluid, and that's why you go immediately to the hospital, because now at this point, you don't have any cushion protecting the baby. So you're kind of, one, ready to push the baby out, but two, you need to prevent from getting hit or any other dangers that could happen there. Okay, then we have our yolk sac. This is nutrition for the embryo. The egg white around the outside really has no nutritional value. Again, that's kind of just the amnion. It's just fluid. We eat it. It has protein, right? But the inside of the egg, where we went through a phase in the health section of the world where it was like, oh, only eat egg whites, don't eat egg yolks because they're high in cholesterol because it has all of the fat in there. Yes, that's exactly what it's supposed to have, because that baby is going to slowly eat the yolk of the egg for its whole gestation period, the whole time it's developing. So there's lots of nutrition in that egg yolk. The egg white is literally just the fluid, the amnion. Okay? The egg yolk is very, very important for nutrition. In humans, sorry for the jump scare of a slide. Humans do not have the same type of yolk, right? We don't have a yolk sac. There's no internal yolk when your mom is having a child. Instead, females, when they get pregnant, start growing a whole new organ. It is temporary. It is only there while there is a baby there. So you sitting in your seats right now, ladies, you do not have a placenta. If you were to get pregnant, as soon as you get pregnant, your body basically triggers a hormone to start growing this massive, massive organ called the placenta. That is basically its nutrition source for the entire pregnancy. This is where the umbilical cord attaches to, and then the other side attaches to your belly button. Okay, and that is the transfer of nutrients from mom to baby. So whatever I eat gets kind of processed in my digestive system, goes into the bloodstream, into the placenta, and then it is also passed to baby. After birthing baby, you have to push out the placenta too, because you don't want to keep that if you're not pregnant. Sorry again. Okay, so we do not have the same thing, just to throw a little comparison in there from reptiles to here. We still are considered an amniotic egg, but we don't have the yolk sac. The allantoy, okay? Toy is a little membrane sac that stores waste. Okay, so this is a waste receptacle, and it helps pass nutrients and gas between the egg and the embryo. But mainly you guys just need to know that the allantoy is for waste. Then we have the chorion. The chorion is a special membrane that surrounds the embryo, amnion, yolk sac, and allantoy. So the chorion essentially covers this whole outside area. If I can get my little pen here. This whole layer outside. So now we have multiple membranes. Okay, this one is kind of your outermost of the important stuff on the inside. And next, the albumin. The albumin is the egg white. Okay, so when you cook an egg and you crack the egg and you're eating all of that healthy egg white, that is the albumin, and it's the water source to the embryo. Remember, these guys are not getting constant water and food from their parents. They are in the egg, and everything that they need to survive for their whole gestation period of growing in the egg comes from inside the shell. So the albumin is its water source. And if you crack an egg, you can see that jelly-like consistency of an egg white is pretty watery. It is jelly, but that's because it has to have a little extra protein in it. And that is for cushion, right? We talk about the amniotic fluid is very similar. It's basically just like a little extra padding in case, you know, the egg gets knocked around, etc. And then lastly, we have a tiny, tiny little space. Okay, and that is for the hatchling's oxygen. That is stored there the entire time for whatever is inside's first breath, which is really, really cool. That's their first little gulp of air once they exit the inner membranes. They take that little gulp of airspace, and then they usually have an egg tooth in the front of their face. You can see it here on this little snake, and that is to crack the egg open. Usually the tooth is shed after a day or two. If they don't have this egg tooth, it's usually because of a mutation and they're not going to be able to hatch, so that will not survive. Okay, so very, very cool adaptation to have this egg and all of the nutrients and membranes inside there. It's very well developed for reproduction and laying eggs on land. Next, we go into classification. This is, obviously we've done this for every chapter. First, we have 4 different orders, right? We are in class Reptilia. Now we are going down into orders. First ones, Crocodilia, crocodiles and alligators. You guys are familiar with these guys. Then we have Sphenodontia. Okay, these are going to be your tortaras. Okay, and then you have Squamata, which are snakes and lizards, and then Testudines. Okay, those are tortoise and turtles and tortoises. Right. First up, Crocodilia, probably the most well-known besides our turtles. You're going to have crocodiles, alligators, caimans, and gharials. Okay, not as commonly known, look just like a small little alligator crocodile. Okay, they have long, thin jaws for catching fish, and they are a separate species because they are fish-eating crocodiles. Most other crocodiles eat other animals. Okay, caimans are closely related to alligators, but smaller, have sharper teeth, and are much, much faster. The gharials are found in India and Nepal. They're pretty endangered because of hunting and habitat loss. You're going to find the caimans in Central and South America. We do have a couple here in Southern Florida, but we don't usually see them. What makes them different from our amphibian friends is that they have an extra palate that divides their nasal cavity and mouth cavity. We also have this palate, which is pretty cool. They're getting more evolved and closer to us. This allows them to breathe even if their mouth is full. Very, very important because as they're chewing, you need to breathe. Okay. This also allows them to breathe when they are partially underwater. Even if their mouth is full of water, they have a separate little section that allows air in. All crocodilians are carnivores. We should know this. You're not going to see a crocodile munching on a little bit of grass. They have strong jaws, a big, powerful bite. Their teeth fall out and replace continuously. This is something they have in common with sharks. Okay, if their teeth break and fall out, they have basically a conveyor belt ready of teeth coming in. Their teeth are hollow, which is pretty cool. So those new teeth actually come up from within the old teeth. So in case one sharp tooth broke, there's a new one right there ready for it. They can have 3,000 teeth at a time. Okay, so lots and lots of teeth. Don't want to get bit by one of these. Saltwater crocodiles have actually the strongest bite force of any animal on Earth. Most people think it's a hippo, but actually it's a saltwater crocodile. They have a two-chambered stomach. Okay, their first chamber is more muscular and has a bunch of stones to kind of break up the food. They also swallow what's called gastroliths or stomach stones to help grind up food. The second stomach is very acidic. Okay, it can break down bones, feathers, and horns. So your first stomach, think about like a mill where it's just crushing everything up. You've seen videos of alligators and crocodiles eating other animals. It's not clean and it's not tiny little bites and they're not chewing it much. They're taking a big chomp and swallowing it. So that first stomach really needs to grind everything up. The second one is more acidic. Think of it like a toxic sludge where all of the bigger portions that they can't necessarily chew kind of melt and get broken down. Crocodilia have a very, very complex and advanced brain compared to other reptiles. They also have a four-chambered heart, which is what we have, rather than a three-chambered heart, which is what most other reptiles have. They can actually slow down their heart rate on their own when they dive underwater, so that they can kind of spend more time hunting underwater. There's also some theories that they have an extra heart in their valve that helps them stay submerged longer as well. We haven't found that out for sure yet, but that's a theory. How to tell them apart. Alligators have a U-shaped jaw, okay? So their jaw is a little bit wider and U-shaped. Crocodiles have a very pointy. For alligators, their top jaw is wider than the bottom, creating an overbite. An overbite is when your top teeth come over your bottom teeth. Crocodiles have the same size, okay, where their teeth kind of interlock with each other. Alligators also, when their mouth is closed, you can see the teeth of their front jaw only. Okay, you can't see any of that under jaw. That is part of having that overbite. And then when crocodiles' mouths are closed, you can see both kind of interlocked. Alligators are a little more freshwater. Crocodiles prefer saltwater. Crocodiles usually get the rap that they're a little more mean and aggressive. Okay. We have Sphenodontia. Okay, these are our totaras. Only in New Zealand. You will not find these guys anywhere else but New Zealand. They're endangered, threatened by habitat loss, and also these rats that kind of came in and invaded New Zealand and started eating them. They are equally related to snakes and lizards, but they're actually not a type of lizard. They just look like it. They are very, very old, expected to be related to the time of the dinosaurs. They have 2 rows of tiny teeth on their upper jaw and 1 on their bottom jaw, and they actually have a 3rd eyeball on the top of their head, similar to arthropods that is sensitive to light. So they have their normal eyes on either side, and then they have an extra eye for light on top. We don't really know why they have it or why they've kept it so long, but many suspect it allows them to judge time of day or season. Something has to be beneficial for them to keep it. They have a very simple heart and a brain compared to other reptiles, not the same as our massive crocodiles. These guys eat insects and spiders, again, very similar to our lizards, but not necessarily in that group. Squamata. Lizards, worm lizards, and snakes. Okay, these guys have a jawbone, okay, a quadrate jawbone that allows the upper jaw to move and open and basically unhinge to swallow prey whole. Okay, so these guys don't necessarily chew their food. It is not true that they actually dislocate their jaw. Their upper jaw naturally moves and just opens a little bit wider. Okay, some lizards are famous for going after some huge meals, like our Burmese python was seen eating an alligator in the Everglades. So they can actually open their mouth extremely wide depending on the size. Obviously, that Burmese python must have been pretty big because it can still open their mouth pretty large. These guys shed their skin completely many times per year. Okay, I'm sure you've seen this before, especially if you have a pet snake or a pet reptile, a bearded dragon, etc. They're the only reptile group, so squamata, the only ones that have viviparous and ovoviviparous babies. Okay, viviparous means that they're laying eggs outside their body. They're carrying their young inside their body. Ovoviviparous means that they lay eggs, but the eggs are kept inside the parent's body. Okay, so we are viviparous. We have one baby inside our body at a time, and we house them and grow them in our body until they're ready to, quote unquote, hatch or be born. Ovoviviparous means that if someone was to get pregnant, they would have an egg sitting inside their belly. All other reptiles are oviparous, which means that they lay eggs. Okay, then we have lizards, geckos, Komodo dragons, and iguanas. 4 legs, really good at running, jumping, climbing. We see these all over down here. Some of them are legless, which is interesting. They look like a snake, a grass lizard. They have eyelids that move and external ears called tympanum, which are these little drum-looking things over here. Good hearing. These guys can change color and camouflage. We talked about this with amphibians with temperature. Remember, they're exothermic, which means their body temperature is reliant on the external environment. So when it's super hot out, they will make their skin lighter. When it's cold, they'll make it darker to absorb more sunlight. Many can regenerate their tails and limbs, and then they're also capable of autonomy, which means that if they're getting chased and someone's tail gets bitten, they can actually detach their own tail so that they don't get eaten by the predator. These guys are worm lizards, weird, are legless, okay, and very loosely attached skin. It's kind of like a little coat. They're usually in Africa and South America. They burrow underground. We don't know much about them. Some of them have 2 tiny front legs, like you see in this bottom over here, but most of them look like this guy. Not related to worms, reptiles. And then our most well-known snakes, they do not have eyelids like our lizards. Okay, they do not have external ears like our lizards, no tympanum, but their skulls can detect vibrations, which is pretty cool. They also don't have legs, clearly. Snakes are carnivores. You're not going to see them eating grass. Some of them inject venom with their fangs. The purpose is to kill or slow down the prey. It's just basically chemical saliva. They swallow their prey whole. They do not bite or tear up or chew their food. After they eat, if you have a pet snake and you give it a little mouse friend to eat, they will swallow it whole and you will see that mouse sitting inside the snake for a very long time. They have to rest and let their stomach digest and grind up, right? We talked about that, grind up all of the muscle and bones that they ate, and then in the second stomach, get that acid working to digest it. And lastly, our testudines. These are turtles and tortoises. Okay. Technically, all tortoises are turtles, but not all turtles are tortoises. Okay, we can kind of group them together and say everyone is a tortoise, but not everything is a turtle. Because they both have a hard shell, they both lack teeth. Instead, they have a beak. Okay, they lay eggs on land, and they can live an extremely long time. Okay, tortoises and turtles don't care for their young. They leave their eggs, especially if they're a sea turtle, on the beach and then disappear and let them live their own lives. Some tortoises can live for over 150 years, a very, very, very long time. And that's because organs of these guys don't necessarily break down or become less efficient over time, like most other animals. How to tell them apart? Turtles have flatter shells and really like water, right? Your sea turtles or your pond or lake turtles. Red-eared sliders are really common pets that need water, but also a basking spot. Tortoises spend most of their time on land and they have that more dome-shaped shell. Turtles are going to have flippers or webbed toes, and they'll pretty much eat anything, right? We've seen them eat seagrass if they're a green turtle, jellyfish, they're carnivores, omnivores, meaning they'll eat both. Um, some turtles eat sponges in the water, etc. Tortoises have long walking legs for the ground because they live on land mostly, and they're herbivores. These guys will eat trees, grass, etc. These guys, their body has a nice hard shell for protection, called a carapace. We heard this when we talked about arthropods, right? It's just like a little shield. And then the belly side is called the plastron. So you have a carapace on top, plastron on the bottom. The outer layer is made of hard scales, made of keratin, which is, remember, what your hair and your fingernails are made of, called scutes. And then the inner layer is actually made of bone. And that skeleton, bone skeleton, is actually fused and stuck to their shell. You can dissect a turtle. It is so extremely difficult because you have to cut through bone to get to their organs. That's why they can live so long too, because it is very, very hard to eat a turtle and break down not only the bony skeleton, but that hard shell on top. Okay, so that is your 4 different classifications of reptiles. We'll go on to movement next.